stop blaming your intelligence. And please stop obsessing over which programming language or game engine is the best one to start with. If you are struggling to learn to code, I can almost guarantee it is not because you forgot where to put a semicolon or because Python is too different from C#. The reality is that most people fail before they ever start. They fail because the way they approach learning is fundamentally broken. The failure is systemic, not personal. You aren't failing because code is too hard. You are failing because you haven't learned how to think like a programmer yet. Let's look exactly why that happens. The first and most common trap is focusing on syntax instead of mental models. We tend to treat learning to code like studying for a vocabulary test. You memorize if, for, while, and you think that if you just know all the keywords, you know how to program. But that is like memorizing a dictionary and thinking you can write a novel. You can't. You might know the words, but you don't know the structure. You can write lines of code, but you cannot predict what they will actually do. Consider a simple health bar in a video game. You might know how to write int health is equal to 100, but do you understand the state of the variable? Do you understand that the health variable needs to persist across frames, be accessed by the UI to draw the bar, and be modified by an enemy's damage script? If you only know the syntax for an integer but don't understand how data flows between objects in a game loop, the syntax is useless to you. Programming isn't about typing text. It's the art of controlling state over time. This brings us to the second point. You don't know how to break problems down. This is usually where the panic sets in. You look at the project requirement or an idea you have, and you try to solve the whole thing at once. You stare at a blank editor and you freeze. Real engineering, the actual skill you get paid for, is decomposition. It is the ability to take terrifyingly complex instruction and smash it into trivial, boring little steps. Take a standard RPG attack. If you try to code player attacks enemy all at once, you will fail. You have to break it down, detect button press, place sword and player animations, detect collision with enemy hitbox, subtract number from enemy health, and play sound effect. If you are stuck staring at a blank screen, the problem isn't that coding is too hard, it's that you are trying to make the game instead of make the box move 5 pixels. The step you are trying to take is too big. Number 3 is a painful one because it feels like productivity. You confuse understanding with recognition. We all have been there. You watch a tutorial, the instructor types something out and you nod along. You say to yourself, yes, that makes sense, but that makes sense is not the same thing as I can do this. This is a passive recognition. It's entertainment. You might watch a 40-minute tutorial on how to make an inventory system. It seems easy, but the moment you close the video and try to add a specific item that wasn't in the tutorial, say a potion that stacks to 10, you realize you have no idea how the inventory array actually works. True learning only happens when you are the one typing, making mistakes and struggling without the safety net of a narrator. This leads directly to number 4. You avoid debugging. Beginners tend to treat error messages like personal failures or bad grades. You see red text, your heart rate goes up, and you just guess at a solution to make the error go away. But there is a truth you need to internalize. Debugging is the job. It is not an interruption to your work. It is the work itself. Do not guess. You have to inspect the code. For example, if your character falls through the floor, don't just randomly change the gravity scale or the collider size. Inspect it. Draw debug rays. Check the collision layers. Print the player's Y coordinate to the console every frame. If you aren't spending time fixing broken things, you aren't really programming. 5th, and this is where the most people quit, you expect linear progress. You assume that lesson 2 builds cleanly on lesson 1 and that you will get 1% better every single day in a straight line. But learning complex systems is messy. You go from confusion to clarity and then immediately back into deeper, darker confusion. James Clear talks about this in Atomic Habits. He calls it the plateau of latent potential. You put in the work, but you don't see the results immediately. You are stuck in a worry of disappointment. In software development, game development, this happens constantly. You might spend 2 weeks just trying to get your jump physics to feel heavy rather than floaty. The code looks ugly, the game isn't fun yet, and you feel stuck. Most people quit right there, but that non-linear struggle, that specific frustration with the physics engine, that is the only path to breakthrough. You have to be okay with the plateau. Number 6. You don't build intuition because you don't use constraints. You start with a project that is way too big. You want to build the next Facebook, an open world MMORPG, or the next Skyrim. But when you have infinite choices, you get paralysis. You need constraints. You need constraints to learn. You need to write small, ugly, boring programs. Small programs provide immediate feedback loops. Don't build an RPG, build Pong. Don't build a shooter, build a text adventure that runs in the console. And that's exactly what we do in the channel. A finished, working clone of Snake will teach you more about the game loops and arrays than 5 years of planning a dream game that you never start. 100 tiny finished scripts, programs, will build your intuition faster than one massive project that you never finish. 7. You learn alone and you never explain things. Gaps in your logic love to hide in silence. As long as the idea stays in your head, it feels perfect. But the moment you try to verbalize it to a friend, to a rubber duck on your desk, or in a blog post, you realize you don't actually understand it. Teaching is the highest form of learning. If you cannot explain how your code works in plain English, well, whatever language, you don't really know how it works. Take delta time, for instance. Every beginner copies position is equal to position plus speed times delta time. But if I asked you to explain why we multiply by time, could you do it? By the way, to make movement frame rate independent so the game runs the same on fast and slow computers. If you can't explain it, you don't know it. And finally, the number 8, you think good programmers don't struggle. You compare your day 1 to someone else's year 10. You look at clean code on GitHub or polished indie game on Steam, and you don't see the years of syntax errors, broken builds, and frustration that came before it. You internalize your struggle as incompetence. Let me be clear, experts struggle too. They just struggle more efficiently. When an expert's pathfinding algorithm breaks and the enemies start walking into walls, we don't panic. We don't think we are stupid. Sometimes we know how to isolate the variables and fix it. We know how to get unstuck faster, and that's just practice. Programming is not a test of your IQ. It is a test of your persistence and your methodology. If you are failing, don't quit. Change the approach. Stop memorizing, start breaking things down, and embrace the struggle. That is how you become a programmer. Get better piece by piece each day. And don't expect linear progress. Don't expect things to happen immediately. Don't expect yourself to write bug-free, perfect code. You never will, and nobody expects that. Embrace the progress, enjoy the journey, and don't worry, you will get there. If you want to learn more about struggles and careers, you can check out this video where I explain what mathematicians do and what my days at the Mathematical Institute looked like. That's all for today. Thanks for watching. If you want to see more in the future, don't forget to hit the subscribe button. Ciao!